Hi everyone. Today, we're diving into a common point of confusion in electronics, the difference between an OTA and an op-amp. They might sound similar, but they are fundamentally different components with distinct uses. Understanding these differences is crucial for any circuit designer. Let's break it down simply. First, let's talk about the op-amp, or operational amplifier. An op-amp is essentially a voltage-controlled voltage source. This means you apply a small voltage difference to its inputs, and it produces a much larger voltage at its output. Its primary job is to amplify voltage signals. A key characteristic of an ideal op-amp is its very high input impedance. This means it draws almost no current from the signal source it's monitoring. On the other hand, it has a very low output impedance. This low output impedance allows it to easily drive current into a load without its output voltage dropping significantly. Think of it like a strong power source that can deliver stable voltage even when a lot of current is needed. Op-amps are typically used with negative feedback, often with external resistors, to set a precise and stable voltage gain. This setup makes them perfect for applications like precision voltage amplification, active filters, summing amplifiers, and voltage buffers. They are the workhorses for many analog signal processing tasks where a stable, amplified voltage output is required. Now, let's shift our focus to the OTA, or operational transconductance amplifier. This is where things get interesting and quite different. An OTA is not a voltage-controlled voltage source. Instead, it's a voltage-controlled current source. You apply a voltage difference to its inputs, just like an op-amp, but its output is a current, not a voltage. This output current is directly proportional to the input voltage difference. The proportionality constant is called transconductance, often denoted as GM. Like an op-amp, an OTA also has very high input impedance, meaning it doesn't load the input signal source. However, a major difference lies in its output impedance. An OTA has a very high output impedance, ideally infinite. This high output impedance is characteristic of a current source. It means the current it produces is largely independent of the voltage across its output terminals. This is the opposite of an op-amp's low output impedance. Another crucial feature of OTAs is that their transconductance, or GM, can often be controlled externally. You can usually adjust it by varying a bias current or voltage. This unique ability means you can dynamically change the gain, how much output current you get for a given input voltage, of the OTA. This makes OTAs incredibly versatile for applications where you need voltage-controlled functions. For example, they are widely used in voltage-controlled filters, voltage-controlled oscillators, automatic gain control circuits, and analog multipliers. So, to summarize the core distinctions simply, an op-amp takes a voltage in and gives a voltage out, with low output impedance and typically fixed gain. An OTA takes a voltage in and gives a current out, with high output impedance and often variable transconductance. Both are fundamental building blocks in electronics, but they serve different purposes due to their distinct output characteristics and impedance profiles. Understanding when to use each will greatly improve your circuit designs. Thanks for tuning in today. I hope this explanation clarified the differences between OTAs and op-amps for you. If you found this video helpful, please give it a thumbs up. And don't forget to subscribe for more straightforward explanations of electronic concepts. Your support helps the channel grow. See you in the next video.